Our planet Earth, a blue and green jewel teeming with life. Beneath this familiar surface lies a secret world of immense power and constant motion. This is the world of tectonic plates, the giant slabs of rock that make up the Earth's outer layer. These plates are in a continuous dance, a slow but relentless ballet that has shaped our planet over billions of years. Imagine a jigsaw puzzle, but instead of static pieces, these pieces constantly shift and grind against each other. The Earth's crust is fragmented into these massive plates, each one moving at a snail's pace, just a few centimeters a year. Understanding the forces at work beneath our feet is crucial for our survival. To grasp the concept of tectonic plates, we must first delve beneath the Earth's surface. The Earth's outer layer, called the lithosphere, includes the crust and the uppermost part of the mantle. This lithosphere is divided into several large and many smaller plates. These plates fit together like pieces of a giant jigsaw puzzle, constantly interacting with one another. The heat from the Earth's core creates convection currents in the mantle, dragging the plates along with them. The movement of these plates is incredibly slow, typically only a few centimeters per year. Continents drift apart, oceans open and close, and mountain ranges rise. Our planet's surface is divided into 7 major tectonic plates and several smaller ones. The 7 giants are the African plate, the Antarctic plate, the Eurasian plate, the Indo-Australian plate, the North American plate, the Pacific plate, and the South American plate. These massive plates cover the entire Earth's surface, constantly jostling for position. The Pacific plate is the largest and one of the fastest moving plates. The boundaries between these plates are where the real action happens. It's at these boundaries that we see the most dramatic evidence of plate tectonics, earthquakes, volcanoes, mountain ranges, and deep ocean trenches. The Pacific Ocean Basin is a hotbed of tectonic activity, home to a zone known as the Ring of Fire. This infamous ring circles the Pacific Ocean, stretching from the west coast of South America to New Zealand. The Ring of Fire is home to approximately 75% of the world's volcanoes and 90% of its earthquakes. The Pacific Plate's interactions with its neighbors create a dynamic environment where new land is formed. Mountains are thrust upwards, and the Earth's crust is constantly being recycled. The Ring of Fire highlights the importance of understanding tectonic activity for disaster preparedness and mitigation. Our planet's appearance has changed dramatically over millions of years. Continents that were once joined have drifted apart, and new land masses have emerged from the ocean depths. About 300 million years ago, all the continents were united in a single supercontinent called Pangaea. Alfred Wegener, a German scientist, proposed the theory of continental drift in the early 20th century. Wegener noticed that the continents seemed to fit together like pieces of a puzzle and proposed that they were once joined. The discovery of seafloor spreading in the mid-20th century provided the mechanism for continental movement, leading to the development of plate tectonic theory. Today, plate tectonics is a cornerstone of modern geology. Plate tectonics is the architect of our planet's surface, responsible for the dramatic landscapes we see today. There are 3 main types of plate boundaries: convergent, divergent, and transform boundaries. At convergent boundaries, plates collide, resulting in the buckling and uplift of the Earth's crust to form mountain ranges. At divergent boundaries, plates move apart, allowing magma to rise from the mantle and create new crust. Transform boundaries occur where plates slide past each other horizontally. These boundaries are often associated with earthquakes, as the friction between the plates can cause stress to build up and release suddenly. The San Andreas Fault in California is a prime example of a transform boundary. The Himalayas, the highest mountain range on Earth, stand as a testament to the immense power of plate tectonics. These towering peaks are the result of a colossal collision between the Indian and Eurasian plates. Imagine 2 massive rafts, each carrying a continent slowly drifting towards each other. As they collide, the force of the impact is unimaginable, pushing up the land between them to form towering mountains. This is the story of the Himalayas, a mountain range still growing today. The collision that formed the Himalayas is a prime example of convergent plate boundaries in action. The Earth's surface is a dynamic canvas, constantly being reshaped by the slow but relentless movement of tectonic plates. Over millions of years, continents have drifted across the globe, oceans have opened and closed, and mountain ranges have risen and eroded away. The legacy of plate movement is etched into the very fabric of our planet. The Atlantic Ocean, for instance, is a relatively young ocean formed about 200 million years ago when Pangaea began to break apart. As the continents drifted, the Atlantic Ocean basin widened, eventually reaching its present size. The movement of tectonic plates also plays a crucial role in the Earth's climate. The distribution of continents and oceans influences ocean currents, wind patterns, and the distribution of heat around the globe. We live on a dynamic planet, a planet that is constantly changing beneath our feet. The movement of tectonic plates has profound implications for human life. Earthquakes, volcanic eruptions, tsunamis. These natural disasters are a stark reminder of the immense power of plate tectonics. By studying these events, we can learn to better predict and prepare for them, mitigating their impact on human populations. Building codes in earthquake-prone regions are designed to withstand the ground shaking caused by seismic waves. The study of plate tectonics is crucial for understanding the distribution of natural resources. As we conclude our journey into the heart of the Earth, it's essential to remember that the dance of the continents is not a spectacle of the past, it's a performance that continues even now. The Earth's tectonic plates are perpetually in motion, their slow grinding movements shaping and reshaping our planet over eons. From the fiery birth of volcanoes to the trembling Earth during an earthquake, we are constantly reminded of the immense power that lies beneath our feet. Understanding these geological processes is fundamental to our existence. By comprehending the forces that shape our world, we gain valuable insights into mitigating natural disasters, managing precious resources, and ultimately coexisting with the awe-inspiring power of our planet. Let us remember we live on a dynamic Earth, a planet in perpetual motion, a reminder that change is not just inevitable, it's the very essence of our planet's story.